Now, how does methylene blue cause neurotoxicity? So some drugs which cause neurotoxicity increase the calcium influx during depolarization. So when there are a lot of calcium inside the cell, then it brings water inside, which calls cellular soiling and lysis. So we wanted to test if the same thing happens to methylene blue. For this study, we used in vitro calcium imaging. So what happened is here, in this study, we use calcium dye that attaches to the intracellular calcium, and we can see the intensity of the dye under the microscope. So if drug, then you give the drug. If drug increase the intensity, that means it causes calcium influx. If you know increase the intensity of the dye, that means it doesn't cause calcium influx. So with this technique here, we applied KCl, and you see the nice increase influx of calcium. And when the first application, second application almost similar, then before the third application, when you give KCl, we see facilitation of the KCl response by methylene blue application, and then gradually normalize this response. So which kind of support our hypothesis that methylene blue probably increase the calcium influx inside the cell, which draws more water inside to make the equilibrium, and there is cellular soiling and cell death. And we are still working on this study, so we'll probably need another few months to conclude how these data look like. So we, from our data, we think there's a dual and opposite effect of methylene blue. At low concentration, at less than 0.1%, it is neuroprotective because it produces more ATP by bypassing the electron transport and enhancing the electron transport, I would say. And it produces less reactive oxygen species, which helps in the neurodegeneration and cytotoxicity. At more than 1.1% concentration, the story is complex. If we give you this to the nerve, then it might have a neurolytic actions. It might cause increased calcium influx and cell death. If you give this infiltrate in the tissues, then it produces inflammatory reaction and inflammatory reaction, hyperalgesia. So what about the mechanisms? Whole study we started to explain the analgesic effect of methylene blue, the reverse translation. I would say that I cannot really explain how it produces analgesia, because in our model we did not see any analgesic effect of methylene blue. So what is the take-home message? Take-home message is hot balloon. Slow is the way to go when it comes to the methylene blue. Dilute the methylene blue during the IV push and check if there's a good IV. If IV is not good, then replace the IV or give in a bigger vein, because when it goes to the tissues, infiltrate the tissues, it could cause inflammatory reaction. And when you work with a breast surgeon and rectal surgeon or general surgeon, and make them aware that it might produce inflammatory reaction if they infiltrate in the tissues or they go closer to the nerve, and the concentration more than 1.1%, concentration more than 0.1% is not safe. It is probably not a safe drug to use in peripheral nerve block, although there is some study, some case report shows that it has been used in peripheral paravertebral nerve block. Most important slide, credits. As you will know that we are a small lab, we couldn't do this much experiment without help from our collaborators. Our lab consists of mainly Malcolm Jones and 3 undergrad students. Malcolm did most of the experiments or supervised all the experiments. and Alec Hormon did histochemistry study. Aisha Siddiq and Rachel Cannon did behavioral study. Dr. Simon is very generous to give his lab space to us and allowing us to use his equipment. Dr. Tran is from the pediatrics. He is an excellent molecular biologist. He helped us with the electron calcium imaging study. Irina Kasabova did cell culture and calcium imaging study. Brian McAdams did confocal microscopy study. We have active collaboration going on with the University of Texas, San Antonio with Dr. Kim. Dr. Kim will probably doing in vivo calcium imaging to see the effect of methylene blue. And University of we recently started collaboration with Dr. Uhelski of the Texas MD Anderson Cancer Center. She will do dorsal horn, DRG recording. Some of the slides are available in the YouTube. If you're interested to get the slide, please let me know.